So that last video just gave me an idea to revisit this geometry of the equinox, because what we can also do is just imagine this black line here is the day-night terminator. So everything that we cannot see on our globe is in the nighttime. Everything we can see is in the daylight. But this time I have oriented the tilt of the Earth as it would appear on the equinox, with the sun's rays coming in from the left-hand side. So again, we're looking at our prime meridian here, and you'll see that as it rotates towards the terminator, the longitude line is perfectly in line with the terminator. Now that is the key as to why we see the sunrise at 090 and the sunset at 270 all over the Earth. Obviously not directly at the North Pole and not directly at the South Pole. And there are some small discrepancies which I will address shortly. But those discrepancies don't debunk the globe model, they actually confirm it, and I'll explain why. But let's just look at these sun angles. So again, let's have a look, and I'm just redoing this video because when I was doing it before I realised I wasn't holding the ruler exactly right. Okay, now that was just my bad technique, but don't get confused. If that ruler's not perfectly level with the video, it's supposed to be. Okay, so if we have a look at the angle of the sun's rays coming in, it's at 90 degrees to this prime meridian, 90 degrees to the terminator, and it's at 90 degrees at all latitudes. Okay, so that's why the sun now is setting 270 degrees, 270 degrees, 270 degrees. I'm just trying to watch the monitor on the camera to make sure I hold this ruler level so that we don't confuse people. 270 degrees. So you'll see any latitude, 270 degrees. And that's going to happen all over the Earth on the equinox. Now, one thing I've seen a couple of times recently, Chippy the Chipmunk mentioned it, and I must admit, Chippy, I was actually really impressed with the level of research that you had gone into to notice that very small discrepancy in some of the angles. And I've also seen a couple of other videos where at very high latitudes or very high value south latitudes, there's a slight discrepancy in the angle on the equinox as the sun is rising and setting. Now let me explain why that is. It's because the sun, okay, it takes a while to descend below the horizon like that. And the actual sunrise is when the sun first appears above the horizon. So when the top of the sun first appears, that is the point that they call sunrise. Conversely, on the sunset, when the top of the sun disappears, that is the sunset. Okay? Now the discrepancy is occurring because of this reason, because they're not measuring the sunrise and the sunset from the center of the sun. If they were doing that, there would be no discrepancy at all. Okay, and the length of daylight and nighttime would be a lot closer to 12 hours day and night. But the main thing is here is that at the equator, when the sun's setting, it's going basically straight down on the equinox. As we move to much higher latitudes, it's not going straight down, it's moving more like that. Okay, so on the equinox, at a high latitude, the sun is setting like that. And remember, if we measure from the center of the sun, there's the center of sun on the horizon. Now we're at 270, but because we're measuring from the top of the sun and it's continuing to descend at an angle, by the time the top of the sun hits the horizon, it's moved away from 270, and it's only by a couple of degrees, but that is the discrepancy you're seeing. It's not a flaw in the globe model, it's actually confirming the globe model. Those little discrepancies of a few degrees you're seeing on sunrise and sunset on the equinox at high latitudes are confirming we're on a globe. It's evidence we're on a globe, because the sunset is when the top of the sun hits the horizon, not when the center of the sun hits the horizon. That is the reason for the discrepancy.